What's up, guys? Welcome to Concept Recap channel. And after finishing introducing the course, it's good now that we should start. So this is where the journey begins, and we will start with separable differential equations. But we have this course is divided into mainly two categories. We have first order differential equations and second order differential equation. So for the first order part is the one that we have some types of first order differential equations. And first order means that the highest derivative in the equation is just first derivative. So that's first order. So now the first class is this separable differential equations. So what is the goal? The goal is that we want to integrate our differential equations so that we can find the original solution, or there's a general solution or particular solution depending on, we shall see what I mean by that. But so separable ordinary differential equations, what it means is these are type of differential equations that that can be separated. Well, so assuming that, for example, if you have y prime is equal to g of x like this over f of y. So if this is, you have something like this, y prime can be written as dy dx. So this will be equal to, like we just maintain the other side, and this is just the same thing. And now you can separate, whereby you have dy. So you take dx to the other side. So what it means is you have f of y means that it's a function only that has y inside. There's no x or any other variable. And gx means that there's only x. So gx has dx and f of y has dy. So we have separated like this. So if you can rewrite your differential equation in this form, that means that is separable differential equation. So now I shall give you the steps in solving separable differential equations, and the steps are as follows. We shall also solve one question and apply those steps so that you can see how we use those steps to apply and eventually find the solution. So steps for solving ordinary differential equations. Yeah, so I hope you guys can see that these are the steps. So the first step is you separate the differential equations in terms of f of y dy, g of x dx, as we have done here. So this is the first step. And if you have done that, then you need to, then the second step, that is to integrate. So you integrate both sides. So if it's not an initial condition, you just integrate and you find the general solution. So, but if it's an initial condition whereby you have been given some initial values, then your integral becomes like this, whereby you just substitute. Here there's a mistake, sorry. So here will be of x. So that's how you do it. And then lastly, you solve for y. So we shall look at examples. I have one example for the general solution one, and then another example will be for the initial condition. And I have to apologize, guys, that I didn't talk about initial solutions, initial value problems in the introduction. It was supposed to be there, but that you shall see, you will still more understand what we mean by that as we get along, because there will be a lot of questions that also require you to find the particular solution given the initial value solutions. So that's it, guys. So let's look at an example about how we can apply these steps. So our first example will be example 1. and it will be x y prime is equal to y. So this is an example. So you have to solve this following the steps. So you can pause the video and attempt it and see if you can find y, and you can find the solution. So so as we will proceed, now what you have to do now is to rewrite in the form y, this y prime to be something like this. So after that, then you're going to separate, as we said. So you can separate as follows: dx and x can go to this side, and y can come to this side. So you have y. If y comes to this side, it will be 1 over y. And if x goes to this side, it will be dx, and it will be 1 over x dx. So that's how you can do it. If you got it wrong, then you just have to check your mathematics, operations. But this is how you do it without violating any mathematical operations. So then, if you have separated like this, then the next thing is to integrate as the second step. So you integrate. So let's now integrate both sides. So now you know that the integration of 1 over x is what? Is ln x. Is ln y. So you can keep the constant because you eventually have a constant also here. So, and the integration of this, it will be the same, ln x plus c. So that's it, guys. You can stop from here, but the third step is optional. You have to find y, so that your equation it should be y as subject of the formula. So you can do that by introducing these exponents, both sides. So you have something like this. Now, if you have done that, then you have y as here, because this exponent will cancel, and this side also they will cancel. But laws of indices, laws of exponents rather, is that you multiply these guys. So you shall have your solution as c of x. You shall have your solution as c of x. So this will be your solution for this particular problem. So we shall have more examples in the tutorials, mostly examinable examples, questions, examinable questions. So stick around and go and check those questions. I hope you understand what is separable differential equations, and see you next time